The trick is when you look up your calculator, it'll say ln x. Oh, sorry, when you look up your tables, it'll say ln x is the original, and when you differentiate ln x, you just get 1 over x. Is that all right with you guys? What you know is about the base of every function? What you know is about the base of every function? They're all base e. So what are they basically all? They're all ln's. If you have a base e on the bottom, it clarifies as ln. So question 1 is actually y equals ln 5x. Okay. Now remember, ln x differentiates into 1 over x. So Darley, what do you think ln 5x differentiates into?
1 over x.
So the x appeared where? So what do you think? Now 1 over 5x is most of it correct. And then what you do with the 5x? You differentiate it and you get 5. And then what's your answer? Which is 1 over. Cool, you alright with that? Alright, you do part 2, off you go. Alright. Charlie's going to do the next one. Now, Charlie is saying it's ln 2x plus 3. So Charlie, what's your answer? 1 over 2x plus 3 is a good start, Charlie. Exactly. They are that easy. Then just differentiate what it was, and now you get 2, and then your answer is 2 over 2x plus 3. Question, Oscar. Little what? Oh, it's gone. Logs differentiate into 1 over x. Oh, sorry. At the very beginning. Log base e. Log base e is ln x. When you see ln, you can swap ln out for log base e. The base e is included as part of the ln. Alright? Alright, Ben. We're going to speed you up on what you missed. You missed tons. You're not going to be able to catch up. Alright? So here's all what you do, Ben. Listen really carefully to me, right? 1 divided by whatever is in the bracket. Differentiate what's in the bracket. Off you go.
2x minus 6.
2x minus 6 is what happens when you differentiate the bracket. Yep. And what did I say before that? 1 divided by whatever's in the bracket, then differentiate the bracket. So what are you missing?
1 over x squared.
Yeah. Yep. And you're fully caught up now. Honestly. That's it. Alright, go on. Question 6, off you go. What Oscar asked me earlier was, he's wondering what happens when I change this into ln cos 3x, okay? I haven't differentiated yet. But basically ln means log base e, okay? Now do that trick I told you earlier. 1 divided by what it is, differentiate what it is. Off you go.
1 over cos 3x.
Yeah.
Minus
Yeah, cos turns into minus sin 3x. And what you do with the angle, Ben? The 3x part. When you do trigonometric differentiation, you change cos into sin, which is correct, but you also differentiate the angle. So I'm saying you differentiate the angle. So minus 3 sine 3x. So what's your answer then? Now Ben, the lads will look at the back of the book and they'll tell me I'm wrong. They'll say the answer is minus 3 tan 3x. Where'd you get the tan 3x from? Yeah. Did anybody get tan before I did? Alright, good job. Alright, that's good. We've successfully done 1, 2, 5, and 6. Alright, let's keep going. I'd say so, but it's not clear though, is it? Like, alrighty. Yeah, we'll do one of these each. Okay. Alright, which one do you want me to do? You just pick the last one always. It doesn't really matter if it's more difficult or not. It turns out 8's probably more difficult, so thank you. Right. Alright, lads. Connor chose the quotient rule for me. So that's U and that's V. Alright, Connor. What happens when you differentiate ln x? What you get? What? When you differentiate ln x. Differentiate ln x. Charlie. No, too late. Was it? 1 over x. Lads, for the last time, it's 1 over whatever is in the bracket, then differentiate the bracket. What happens when we differentiate that bracket? We get 1. Nothing to worry about. Alright, what about b, lads? B. B is x. So what's the v dx? 1. Alright, then we take out the quotient rule. And we do v times the u dx minus u times the v dx all over v squared. And what do we get here? X times 1 over x, yeah. Ln x multiplied by 1, not bother. All over x squared. Right. Please remember, ln x does not obey normal maths. So for example, if this was a 2, you can't say that's ln 2x. It will be 2 ln x, okay? So there's a difference. I'll actually just run through that now while I'm here. Alright lads, just so we're clear, okay? ln x multiplied by 2. Alright, we see it? The 2 goes to the front to make it 2 ln x. 2 could hop in there and make it ln x squared. If you don't remember an exam, here's my advice. Okay? Imagine log 10 base 10 multiplied by 2. Okay? If you put a 20 in there, the answer is 1 multiplied by 2, which is 2. If you change that to 20, the answer will no longer be 2. But if you bring the 2 to the front, and then you put up the 2 besides 10, it becomes 10 squared, which is 100. And what's log 100 base 10? 2, exactly. Now, I'm just making sure that doesn't happen to you in the future, okay? But back to where we were. We did the quotient rule, and we're going to multiply this out. So it's just going to be 1 on top minus ln x all over x squared. Everybody cool with that? Alright, you guys are now going to do question 8. Let's go. Alrighty. So, what we're hoping you did here was you identified it as the product rule, where that's u, that's v. Okay, you went over here and you said u equals x squared, the u dx equals 2x. Then you said v equals ln 3x. And then Oscar, what did you call the v dx? Was it? Yeah, so 1 over 3x, differentiate the function part, which is 3, which is 3 over 3x, which is the same as 1 over. Good. Now we're going to do the product rule. And we're going to get u times the v dx plus v times the u dx. And here's what we get. X squared times the v dx, which is 1 over x. Plus v, which is ln 3x, multiplied by the u dx, which is 2x. Now, this 2x is not allowed multiplied by the 3x, is it? Where does it have to go? Go to the front. And that just leaves x there, doesn't it? So what's the answer? Done. Doesn't look like a proper answer, does it? Alrighty. Alright, here's how you do this one. Right? First of all, you change it into y equals ln 1 plus x squared. You cool with that? On the outside, I'm going to put what? To the power of half. Now what we're going to do after that? Bring the half where? To the front. And if you do it this way, you greatly reduce the amount of craziness you have to do. You should not try it any other way. It will not be fun. Now that's when you differentiate this. So, just imagine this is the differentiable part. Does that make sense? If you differentiate a half x, what would your answer be? A half, wouldn't it? If you differentiate a half 3x squared, what would your answer be? A half of 6x. Just concentrate on the differentiable part. So, looking at the green part, what's the answer to that? We'll go for Haynes. Yeah. And differentiate it. Okay, and what's 2x divided by 2, Haymans? And what's the answer? Alright. What page are we on here, guys? 298. You guys do this one now, please. And part 2. Okay. Leaving my board, so you better be on. Alright, so y equals ln. This is so nasty. Who's doing the quotient rule? Alright. Who's not using the quotient rule? Yeah. Don't do the quotient rule. It can be done, but you don't want to do that to yourself. So here's what you do instead. Before you differentiate, you use the division rule, where you do like this instead. Everybody see that? So ln 5 over 4 is the same as ln 5 take away ln 4. It's the fraction rule, okay? So you do not want to have to differentiate that as part of a quotient. It would not be a nice way to go, nice way to do it. Okay, it can be done, and I've done many of them in the past, but they're not worth it. Okay? Now here's what you're going to do instead. Alright, Daily, 1 over it's differentiated. 1 over differentiated. And the other one? Differentiated. And some of those poor buggers doing the quotient rule right now, they're not even halfway there, and we're pretty much done. Alright, what would you do to finish this off, maybe? Would you get a common factor? And yeah, you'd probably do that. Alright, so let's do that now. The blue parts are the parts I put in extra. To make sure we get a common denominator. So I think what I'm going to get on here is 2 minus 6x plus 6x plus 3. I'm not even going to multiply that out on the bottom because there's no point. And did anybody get 5 over 2x plus 1? 1 minus 3x? Alright, lads. Now, alrighty. So, what I'm seeing here is, I'm seeing a power, okay? And when I see that power, I'm thinking, why don't I move that 2 to the front to make things a lot easier? So I'm going to go for y equals 2 ln 2 ln x squared plus 4. Have I actually differentiated yet? I haven't even differentiated yet. Now I'm going to differentiate. Okay. So, Shane, how'd you do this? Yeah. Differentiate it, 2x. Then what's your answer then? Handy, isn't it? It's handy when you do the prep work properly. If you don't do the prep work properly, it actually gets a lot more difficult, okay? So you guys are now going to try on your own this one. The one that the man himself chose for you. Alright. Alright guys, the last one, okay? So what we're seeing with the last one is, the last one's quite a complicated question. So do a lot of prep work. First change it to ln. Then change it into root x divided by root 1 plus x. Who did that much? Right. Next thing, break up the logs using the subtraction rule. Do y equals log ln root x minus ln 1 plus x. Who got that far? Still got more preparation. Haven't even differentiated yet. X to the power of a half minus ln 1 plus x to the power of a half. Now and only now am I ready to differentiate, okay? So what you get when we differentiate this? A half. Oh, I didn't do all my prep yet either, have I? I shouldn't even differentiate yet. Still not ready to differentiate yet. Bring the half to the front. A half ln x minus a half. Yeah, ln 1 plus x. Still haven't differentiated yet. Okay. Now I'm going to differentiate. So, leave the half alone and space you just 1 over. Then leave the half alone. Then 1 over what it is. Differentiate what it is. And now we're very close to having this done. 1 over 2x minus 1 over 2 into 1 plus x. Alright, how do I get one fraction? Which is? Put an x there and a 1 plus x here and here. And what we're going to get now? 1 plus x minus 1 all over 2x into 1 plus x. And we get yeah, no, but the x's can cancel then, can't they? Oh, sorry, I got it wrong. Yeah, I'm wrong. Just 1, isn't it? No.
I think you.
Who got 1 over 2x into x plus 1? Okay. Who didn't get? Who has a different answer that they think is right? Okay, what do you get?
X over 2x times 2x plus 1.
Alright, so we agree on the denominator, do we, Jamie? Agree on the denominator. Just give me a sec. I'm sure it's probably me. Oh, sorry. That's. Alright, let's go back a few steps. Look, just best to redo it and see what happens. Alright, lads. Who got a half ln x plus a half ln 1 plus x? Great. A half goes straight through. Ln x changes to 1 over x. The 1 plus x changes into 1 over 1 plus x times 1. The minus a half is still there. Everybody cool with that? Then I decided to say 1 over 2x. And then this is 1 over 2 into 1 plus x. By adding a 1 plus x onto this side, like so, and then adding a x onto the other side, does that not balance off the denominators? Does anybody see a mistake there? Yeah, I can, but there's no need. I'll tell you what, I'll do it that way in a second, and if I get the same answer both ways, I'm in business, okay? And then I'm about to get 1 over 2x into 1 plus x. What does the back of the book say? Does it? Alright. Now, so I look at this and I go, okay, that's ludicrous to say the least. Okay, it's a chain rule though. Fundamentally, it's a chain rule. So, for example, is if you had something like this. So, first of all, what it actually means is you could do it. You could do it like this. You could do it as ln x plus 4 by ln x plus 4. And you could actually do the product rule if you wanted. You could do that as the, sorry, wrong choice of color. You could do that as u, and this one is v, and you could do the product rule if you really want. That makes sense. Now, my suggestion would be that we do the chain rule instead. So, what I'd say is that we simply do what we always do. Daily, where does that 2 go when you differentiate in the chain rule? 2 goes to the front. What happens to the chain? Does it change or remain unchanged? Or do you not remember? Huh? Leave it alone. Okay. And what do you do with the part then? You differentiate at the very end. What do you get? 1 over? Yeah. I think this is a typo. I think it actually is the YD. Actually, just made a typo. Because I'm about to get that answer now, haven't I? That was actually a lot less adventurous than I thought it was going to be. Sort of disappointed. Am I allowed to cancel the x plus 4s? No. No. Old. Alright. How would you prove to yourself that you're not allowed to cancel them? Here's how. By your logic, ln 3 over 3 should be ln 1 by your logic. Correct? Then, by Brian logic. Alright? So what we're going to do is we're going to try an ln 3 and then we're going to divide it by 3. And we're going to see what Mr. Calculator has to say about that. Right. So ln 3 divided by 3 is 0.366. It's not, and then we can check out what ln1 is. And ln1 is 0. They're not the same thing. So you're not allowed to do what you guys tried. Okay? But you're allowed to check, aren't you? Right? Now, you guys try 14 now. Yes, it is. And I'm doing most of it. 1 sec, buddy. Alright. Alright, lads. So, first thing we're going to do is we're going to find the slope. Is differentiation after all, so we'll differentiate. Now, this is ln x, which we all know is 1 over x. 2, which is minus 2. This is plus 2x. And then we have x equals 2. So that's going to be a half minus 2 plus 4. Did anybody get a slope of 4.5 take away 2, which is 2.5? Anybody get 5 over 2 for the slope? Now that's not the answer to the question. That is one part of the answer to the question. Oh, sorry, the slope. It doesn't actually want the tangents. Ah, it's so soft. Alright, 5 over 2 is the answer slope. Alright. Alright, guys. Now, what we have is ln 1 plus sine t. And what we're going to do is we're going to do dy dt. Okay, so, alright, this one ain't too bad actually. So, what happens when we differentiate it? Christian, that guy. It is 1 over 1 plus sine t, and then what you do with the sine t? Or what you do with this part here? And what you differentiate it? Yeah, cos t, yeah. So you end up with cos t over 1 plus sine t. Now, Christian, this is the fun part, is that you got to differentiate it again. So this is u and this is v. You can pick somebody else too if you want. Do you want to delegate it? Or do you want to go with? What? Who? Alright. Alright, go on. What'd you get for you? Yeah. Shh. To you, DT? Yeah. Jamie, you're up. Jamie, off you go. What's next? You're Jamie. B is 1 plus sine t. dv dt is cos t. Alright, Ben, put it all together, please.
B was 1 plus sine t.
Yeah. Yes.
Minus cos t by cos t.
Yeah. Like that, yeah. All over.
1 plus sine t squared.
Okay, keep going, Ben.
Minus sine t minus cos squared t.
Yeah.
Minus cos squared t.
Alright. Now, there is a bit of a shortcut in here. Do you see it? Does anybody see it? Carl? That is minus 1. Because sine squared t plus cos squared t is 1. Minus sine squared t minus cos squared t is in fact minus 1. Alright, now Carl, there's yet going to be another shortcut in here as well. Any idea how to get yet another shortcut out of this? Nearly. What happens if I factorize out minus 1? What happens if I factorize out minus 1? What do I get? And what do you know about that compared to the bottom? So what can I do? And what's left? Minus 1 over 1 plus sine t. Alright, I'm so far into this question I can't remember what I'm meant to be doing. So, at this stage you go all the way back to the top, and I suppose what we do is we highlight this as our second derivative. Where's our first derivative? Somewhere in there. Where did I get the first? Oh, there it is. That's going to be second derivative. There's our first derivative. Okay, now what does it want from me? It wants me to do 1 plus sine t multiplied by the second derivative plus k equals 0. Alright, that's not so bad. Alright, 1 plus sine t multiplied by the second derivative plus k equals 0. Alright, that's handy enough now. Ben, what is the second derivative?
1 over 1 plus sine t.
Yeah, and then what happens then?
0.
Yes, what happens then? What cancels?
1 plus sine t.
And then what's left over?
Minus 1.
Plus?
K.
And then what's k equal to?
1.
1. Alright. You guys start 17, alright, and I'll just see what I did today.